In this video, I will show you how I built a simple EHD generator that I use for my Plasmaculture experiments. If you are new to Plasmaculture, please watch my previous video on this subject where I also discuss about electroculture. I will provide a link to that video at the end of this one. Today we take it up a notch and I will discuss some design elements to consider when building a EHD generator for Plasmaculture. But before we start, a word of caution. What follows involves working with high voltage and electrostatic elements. People not familiar with electric components and people with pacemakers should not attempt to replicate. Also, air ionization is known to produce ozone, which can have some negative effects on health, especially in non-ventilated areas. People with existing respiratory conditions, such as asthma, should not attempt to replicate. The simplest way to generate plasma with high voltage is to produce a spark discharge. However, this method has two issues. The first one is that the direction of the spark between the two electrodes is random. So depending on the setup, directing the plasma to a target object can be difficult. For example, here I'm having some issues with directing the spark to the water. The second issue is that an electric spark is hot. When applied directly to living materials such as seeds or roots, an electric spark can damage the living tissue. EHD solves the first issue. EHD stands for EletroHydroDynamics. In a nutshell, the charged particles in the plasma are moved and directed by an electric field. And I will use the corona effect to solve the second issue, as this effect produces a cold plasma through ionization of the air molecules. The power source of the EHD generator is a high voltage power supply. There was a time when producing high voltage at home was only reserved for math scientists and engineers. But they had to repurpose all giant CRT screens to fabricate their generators. These days, boost step-up power modules are readily available online in neat little packages. They usually take in direct current and can be powered by standard batteries. For my setup, I use a high voltage power module that takes in 12 volts DC and I power it with a 12 volts AC to DC switching regulated power supply. I find this setup more convenient and stable for my experiments, as I have tried other batteries and power supplies playing around with these high voltage modules. Next, let's move on to the central piece of this EHD generator, the two electrodes, often called the emitter and the collector. I use a thin copper wire and a copper pipe. The thin copper wire will serve as the emitter. In fact, it serves two purposes. The first one is to ionize the air and generate the plasma with the corona effect. So the wire has to be very thin. The thinner it is, the more efficient the ionization will be. I will not go below 30 gauge. In this setup, I'm using a 44 gauge copper wire. As a reminder, the higher the gauge number, the thinner the wire. The second function of the emitter is to generate an electric field between it and the collector. The second electrode is called this way because the ions will travel from the emitter to the collector and accumulate on it. I'm using a leftover plumbing pipe for the collector. Any copper pipe will do. Aluminum also works well. The most important thing is that the collector should not have any edges, and its surface should be as smooth as possible. If the surface of the collector is not smooth, or if there are edges, a corona effect can take place there and decrease the overall efficiency of the EHD generator, because the collector will also act as an emitter. The rest of the EHD generator should be non-metallic, in plastic or wood for example, and should provide a stable structure to hold the two electrodes in place during operation. I used two side panels and a thin plastic rod. First, I made the holes for the two electrodes. I made the holes for the emitter at various distances from the collector, 2, 3, and 4 centimeters for example. More on that later. Next, I wrapped the thin emitter wire around the positive output wire of the high voltage module, and I used electric tape to secure the connection. Before connecting the emitter wire, it's a good idea to remove its thin coating with sandpaper. Usually the polarity of the input wires of the high voltage modules are clearly indicated, red for positive polarity for example. However, the high voltage output wires are often the same color, so there is no way to figure out which output wire is positive. More on that later. Now comes the assembly of the various components. First, the collector. Then I insert the emitter wire at 2 cm from the collector. It's better for the high voltage module lifespan to start closer to the collector and progressively increase the distance after successful trials. Next, I insert the plastic rod. The function of the rod is to increase the stability of the assembly. I also find that the rod increases the strength and stability of the plasma. I make sure the emitter wire is at the bottom of the rod so that it faces the collector directly. Finally, I connect the negative wire of the high voltage module to the collector. Now it's time to connect the EHD setup to the power supply. Turn it on, et voilà. Oops! There should be no spark discharge, only a light hissing noise indicating the presence of an ionic wind between the two electrodes. The loose end of the emitter wire needs to be taped so that it does not bounce around and cause the spark discharges. The stable hissing sound indicates that the EHD generator is functioning properly. The denser the emitter wire is, the more efficient the EHD generator is, but the thin copper wire can snap if too tensed. Usually with these little high voltage modules, the output current is too small to see the plasma between the two electrodes when the lights are on, but the plasma should be visible in a darker setting. In this configuration, the emitter is at 2 cm from the collector. Depending on the characteristics of the high voltage module, the distance can be increased to 3 or 4 cm. The farther apart the electrodes are, the higher the ion's velocity is when they impact the collector, since the particles have more distance to accelerate in the electric field. However, the farther apart the electrodes are, the weaker the ionization is. I'm using this setup to experiment with seeds and cuttings. This study from Croatia and Hungary shows that plasma induces hormonal changes and polyphenol responses in wheat, leading to significant stimulation of germination and growth in both shoot and root. Interestingly, in this case, the study found that plasma did not exert its effect through stimulation of growth hormones, but actually triggered a stress reaction. It is also interesting to note that the protocol the team followed was to submerge the wheat seeds in water and expose them to a high voltage electrical discharge for 30 seconds. From my point of view, tomato or pepper seeds are probably not worth the hassle. But seeds that are more difficult to germinate, like those that require scarification and stratification, could be interesting to experiment with. I have the same mindset when it comes to cuttings. Tomato cuttings are very easy to root in water. The same goes for guava cuttings. I have been having more difficulties with soursop cuttings, so currently I'm experimenting with them. So far, the results have been interesting. The effect of plasma on plants is highly complex and a hot research topic. For example, there are many parameters involved in this deceptively simple EHD setup. I already mentioned the distance between the two electrodes, which determines the number of ions produced and the velocity of the ions when they impact the collector. Also, the strongest ionic wind is usually produced with a positive emitter. By the way, this is one way to identify the output wires of the high voltage module. A positive emitter configuration produces positive ions and less ozone. It is often the preferred configuration. However, it could also be interesting to test different plants with a negative emitter, as it produces negative ions. According to this study, a negative emitter also produces 50 times more electrons than a positive emitter. Experimenting with different exposure protocols will probably also yield different results. Just remember that too much of anything can kill any living thing. Thank you for watching. Drop me a comment if you have a question or a success or a failure to share about your own Plasmaculture experiment with this EHD setup. And don't forget to like and subscribe for updates and more content like this.